of all positive bases b, we can use for the exponential function y equals b of x, which ones are the most useful? This is the question. If you look at the keys on a calculator, and also most of you see some other places in the computer, etc., you will probably see 10 to power x and e to power x. So the base 10 and e is very important. So it is clear why base 10 would be important, because our number system is a base 10 system. But what is the e? And why is it included as a base? It turns out that base e is used more frequently than all other bases combined. The reason for this is that certain formulas and the result of certain process found in calculus and more advanced mathematics take on their simplest form if the base is used. This is why you will see e used extensively in expression and formula that model real-world phenomena. In fact, its use is so prevalent that you will often hear people refer to y equals e to power x as the exponential function. And also you will see from me, when I say exponential function, generally I refer to e to power x function. Y equals e to power x. So this is the exponential function. Unique one. The base e is an irrational number, and which is like the pi, etc. Okay, actually we have some other irrational number, maybe you don't know. It cannot be represented exactly by any finite decimal or fraction. However, e can be approximately as closely as we like by evaluating the expression 1 plus 1 over x to power x. Okay, let's make our observation for the some values of the x. The expression for sufficient large values of x, of course. Okay, so let's make our observation for the x values. What is the 1 plus 1 over x to power x? You can use the calculator. If x equals 1, that is 2. If x equals 10, this is 2.59374, etc. If x equals 100, this is 2.70481. Actually, your textbook used the point as a decimal separator, so let's use the point. If x is 1000, this number is 2.71692. If x is 10,000, this is 2.71814. Okay, by that way it approach to some value. If you calculate the 100,000, 2.71826, of course it will continue for all case. If this is 1 billion, x is 1 million, 2.71828, etc. So, interestingly, the value of the expression, green written expression, is never close to 1, but seems to be approach a number close to 2.7183, etc. In fact, as x increases without bound, the value of this expression, approach an irrational number that we call e. We define by this way. So this approach to number E. Okay, this approach to 2.7183 blah blah blah. Maybe you can write the more accurate case. 281, 828, etc. By writing in your calculator e to power 1, you can see this value.